Zai, a very good morning once again to every individual watching this tutorial. Now, in today's tutorial, we will be discussing about the various types of questions where uh, an will be given to you. Okay, like for example, like this, they'll give you the value of an is something like this, and then they'll say find its sum. So today we'll be discussing how do we approach these type of sums. Now, to go ahead and solve the questions based on these type, what we have to do is we just have to know a few things. Like for example, we have to know sigma n. Whenever I see sigma n, it means that it is equals to n bracket n plus 1 by 2. That's the formula. Okay, and this is the same formula which we had for your single natural. Remember, in the previous tutorial we talked about how the sum of the various consecutive numbers, and for single natural we had this, for the square natural we had this, and for the cube natural we had this. So we will be applying the same formulas, but now just the representation will be a little different. So sigma n, it's like a single natural number, like n plus 1 by 2. Sigma n square is just like your square but and a natural, so it'll be n plus 1, 2n plus 1 divided by 6. Similarly, sigma n cubed, we just modify it. Okay, it's actually, we write it as n plus 1 by 2 whole square, but if I want, I can just apply the square individually, and then this becomes n square, this becomes n plus 1 whole square, and then this becomes your 2 square, that is 4. Remember, we had this as the formula, so we are applying square for the n, also square for n plus 1 and square for 2, and then we get this. Okay, we can directly write this also. And one more important thing, this is something new. If I say sigma n, we can represent it as n. Okay, we can just simply represent it as n. Okay, so let's go ahead and solve one or two questions based on this. Okay, so let's say for example we have a question. So let's say number one, let's say the first question, let's say they've already given us let's say given, okay, the value of an is equals to n plus 2, and they're saying find its sum. So find its sum. So first thing is, I see like this, what you can do is we can just simplify your n a little further. What we can do is we can just open the bracket. So your n becomes n into n becomes an n square plus n into 2 becomes your 2n. So we have this. Now there is a formula. If I have to find the sum, and if an is given, the formula to find a sum is this. Sum can be written as, if you want, you can write this also, but if you want, you can skip it in your class 11 standard. You can write summation, or the total of the entire an. Okay, summation of the entire an. And what is an? Summation an is indirectly n square plus 2n. So that's the formula whenever an is given to you and we have to find the sum. No matter what the an is, we just have to do a summation or a total of that an, and an is already given as this. Now we can, since there is a plus and all in between, we can separate them. So the summation of n squared and summation of 2n. So what we can write is, we can write summation n squared plus summation of 2n. Okay, and this also, now this just now we said there is a formula for your summation n squared, and the formula for the summation n squared is this. So what we'll do is we'll go ahead and apply this formula. So over here what we can do is we can write it as n plus 1 divided by 2n plus 1 whole thing divided by 6. Now over here, if we have a number and n, what we can do, always the numbers we can bring it in the front. It's just like a bracket, we just have to take it in the front. We can write it as a 2 summation n. Okay, so what we do is, so that we just have summation or sigma n squared, because we have a formula. We don't have a direct formula for sigma 2n, but if I take the 2 in the front, and I'll be just left with sigma n, and we definitely do have a formula for sigma n. Okay, so now this one, for the time being, we'll leave it as it is. Okay, n plus 1 divided by 2, n plus 1 divided by 6, and then we have a 2. Now sigma n, what's the formula of sigma n? We have already given you n plus 1 divided by your 2. So that's the formula. Okay, so what we can do is, if you want, we can just go ahead and check. Over here nothing can be cancelled, but over here the 2 and the 2 can be cancelled, so we are left with this. But if you look carefully in these two terms, you have n also over here, you have n over, you have n plus 1, you have n plus 1. So we can take something common. So if there is a possibility of something being taken common, we definitely go ahead and take common. Okay, so we have n plus 1 is common. So if I take n plus 1 common from here, if I take it out, what am I left with? I'm left with 2n plus 1 divided by 6, and plus if I take the n plus 1, the 2 and 2 is already cancelled, there is nothing, means we write a 1. Okay, and down, if you have nothing, means it's understood it's a 1 over here, so we find the LCM over here. So we have n plus 1 over here. When we find the LCM, it's a 6, and then I get a 2n plus 1 plus 6, and then I'm left with, what do I get? We get n plus 1, and then inside what do we have? We have a 2n plus 7, and the 6 means this, now it's all multiplied, so we can write the answer as this one. So we can leave the answer like this. So that's the answer for your sum when an is equal to n plus 2. Okay, that's how we go ahead and solve. So if I am aware of the various formulas like this, sigma n squared, sigma n cubed, and sigma n is equal to n, so I just have to go ahead and apply this. So it's not that tough, it's quite simple. So let's go ahead and give you another example. Okay, so let's go ahead and give you one more example of this one. So let's say, for example, if I have another question. So let's say the question, it says, is given, let's say an is equals to 4n cubed plus 6n squared plus 2n, and then it says find its sum. Okay, so what we can do is we can go ahead and now again directly apply the formula. So the sums formula, okay, this step can be skipped also. Okay, so you can directly write sigma, we know it's sigma n, so we can write it as sigma an, so I can write it directly as this. So that's the formula. Okay, and then now this sigma is individually for everyone. Now if you want, before, okay, this step also can be skipped. Okay, if you want, you can skip this step also. So what you can do is directly, when you do this, you can take out the 4. When you are writing the summation for all the terms directly, you can start taking out the constants, and then you will be getting this, and then you'll be getting this. So if you want, you can directly write this. Okay, so but it's just to explain you how do we get this. So we have done these steps also, but if you want, you can directly write this. So over here now we have sigma n cubed. Okay, and we have sigma n squared, we have sigma n. So now we apply these formulas for each and every sigma n cubed, not whatever we have. Okay, so if I write this one, so this becomes 4 in the front, sigma n cubed, the formula is 1. So we can directly write it as n square n plus 1 whole square divided by a 4, and then for this I'll write 6, and then sigma n squared is 1. It is n plus 1 bracket 2n plus 1 the whole thing divided by a 6, and plus 2. Sigma n is n into n plus 1 divided by a 2. Okay, that's the form. So now if you look individually, okay, if I see over here, the 4 and the 4 can be cancelled, the 6 and the 6 can be cancelled, over here the 2 and the 2 can be cancelled. So what am I left with then? I'm left with n square n plus 1 whole square. Over here, what am I left with? We are left with n plus 1, we had 2n plus 1, and over here what do I left? What do I have? Over here we have this. Now if you look over here, so common means it doesn't mean only 2 of them, it has to be common in all 3 of them. Okay, something same has to be in all. So if you look carefully, there's an n plus 1, n plus 1, n plus 1. There is an n over here, or there's n squared, but I have at least an n, I have an n, I have an n. So what I can do over here is I can take n plus 1 common. So from the first term, if I take n out and n plus 1, I'm still left with n plus 1, because there are n square, so I have taken out 1 n, so I'm left with 1 n. There is a square, I've taken out 1 entire n plus 1, 1 entire n plus 1 is left. So plus, now n plus 1 is out, so what I'm left with? I'm left with 2n plus 1, and over here we have taken the n plus 1, everything else, so we are left with 1. Okay, so now this remains n plus 1. So what about this one? If I open the bracket, what do I get? N square plus n plus 2n plus 1 plus 1. So we look for like terms over here. So do I have any like terms? Yes, definitely we do have like terms. These two are like terms. I can write n square, n plus 2n is give 3n, and 1 plus 1 will give me a 2. Okay, so if you want, we can leave it like this, but if you look carefully, this can be solved using your middle term factorization. So I can do it like this. So middle term factorization is n square plus, I can write it as a 2n plus n plus 2, and then n plus 1. Then what will be? N is common, n plus 2 over here 1 is common, n plus 2, and then over here is n plus 1, and again I can write it as an n plus 2, and I can write it as an n plus 1. So that's the final answer. But if you look over here, these two are exactly the same. Well, I can write the final answer as n plus 1, the same thing, square, and an n plus 2. So that's my final answer for the sum. So this is the answer for your sum when you have your an given as you have how much? You have 4n cubed plus 6n squared plus 2n. Is that okay? So that is the way to go ahead and find. That means the sum, that's the formula. And if you want, these two steps can be skipped. You can directly write this. So if you have your an, so you can already take out a 4, straight away you can take out a 4, and you can write sigma n cube, and 6 is also taken out. So usually the constants are the ones that we take out. Okay, so let's give you another example. So let's give you one more example. Okay, so let's say this one. So we have an given to us as 4n square minus 4n plus 1. Okay, and then now they're asking us to find the sum. So over here I've skipped a few steps. So what I've done is sum, the 4 that is the constant is already taken out. Then we have a sigma n square, that's the formula, minus 4 is taken out, sigma n, and plus over here is the constant, so we write sigma n, a sigma 1. Okay, clear? So if there is only a 1, then we write 1. Okay, and sometimes what will happen is if I, let's say instead of a 1, supposing instead of 1, if we had, let's say 4n square minus 4n plus, let's say 12. Okay, sometimes you may have not just a 1, you may have any number. So this, how will I write? I'll write it as a 4, and I'll write sigma n square minus 4, I'll write sigma n. Then how do I write this? You have to imagine that this is like 12 into 1. Imagine it's like this. So what we do is the constant, whatever is apart from 1, that comes out, and then we write sigma 1. We always have, because there is a formula for sigma 1, because we have to start expression those numbers, and whatever number is there, we have to express it in terms of 1. If you have only constants, okay, express it in terms of 1. And how do I do it? So if I have 12, I write, imagine it's 12 into 1, so the constant comes out and the 1 stays inside. If I just have a 1, if there's nothing, then the 1 stays like this only. Okay, so you be very careful with that. Okay, and then now this is sigma n square. Now we already know the formula of your sigma n square. So that is n plus 1, 2n plus 1 divided by 6. Sigma n has this formula, and sigma 1 we already said is equal to your n. Sigma 1 is equal to n. So we write n. So over here what happens is that now I can do 2 2s are 4, 2 3s are 6. Over here also I can do a 2 1s are 2 2s are 4. So what am I left with? I'm left with 2. Then inside is n plus 1, 2n plus 1 by 3. Minus we are left with 2 n plus 1 by 1 plus 1. Okay, plus n, sorry, not a 1. Oh, now if I look at these two, we have n plus 1, n plus 1 common. But over here there is no n plus 1 common. So I can just take these two, and I can take common, and I can just keep on writing this, and at the end I can solve it. That is also one possibility, where you just take common between the two of them, and this later on at the end you solve it. But at times some of them they find a little bit confusing, so I just avoid that. Okay, but if you want, you can just take 2 at a time, and then the rest you can do later. But right now for the time being we will not take common. So over here what we do is we just open the bracket. So these two, when I multiply, what do I get? It's n into n gives me an n square, n into 1 will give me an n, and then this as it is 3. Okay, this again I get an n squared plus n by 1 plus n. Now again these two when I multiply, so if you know what you can do it is you can do it in the rough. Okay, so what you can do, this n squared plus n, 2n plus 1, I think everyone knows how to solve it. But if you want, then n squared plus n 2n plus 1, it's this into this, this into this, this into this, but this, or you can write n squared into 2n plus 1 plus n into 2n plus 1. You solve it, and then you'll get this much. Okay, so you get 2n cubed plus n squared plus 2n squared plus n, and then this when I again multiply it. Okay, so it's 2n squared plus 2n. So I'm not opening the bracket because there is a minus. I'll open the bracket only when later on I find the LCM. So I'm keeping this bracket as it is. Okay, because if I open it right now, the signs will change again later on. I may make errors. So right now we're not opening the bracket. And over here I see common, so again 3n squared, and we get this. Okay, now again with this I multiply. What do I get? I get 4n cubed plus 6n squared plus 2n by 3 minus this is as it is plus n. Okay, this also if you want, it's like a 1. So now I find the LCM. 3 1 is the LCM is 3. 3 1s are, this remains as it is, minus 1 3s are, 3 will multiply the entire 2n squared plus 2n plus 3 into n will give me a 3n. So now when I open the bracket, okay, this remains as it is, minus into plus is a minus, 3 2s are 6, minus into plus is a minus, 3 2s are 6, over you get over. Now once I've done this, what we do is we start looking for like terms. So first we look at the highest power, that is n cubed. Does it have any other n cubed? No, it does not have, so n cubed remains as it is. Now if you look at this, 6n square minus, so this is a plus, this is a minus, they get cancelled out. Okay, same in the values but different signs, they get cancelled out. We have a 2n and 3n gives me a 5n, but we have a minus 6n, so the greater one comes, the sign of the greater one comes, so we get a minus n. Now over here what we can do is, if you look carefully, what we can do is we get 4n cubed minus n by 3. So n is common over here, so we have n by 3 and then 4n squared minus 1. So we can leave the answer like this, but since we are in class 11, so what we have to do, if you look carefully, this can be further solved as this one. Okay, so we can write this further as n by 3. This can be written as 2n whole square minus, I can write 1 as 1 square, and then if you look carefully, this becomes in the formula of a square minus b square. So it is in the form of a squared minus b squared, and the formula of a squared minus b squared is a plus b, a minus b. So this is a, so a plus b, a minus b. So that's the final answer for this particular question. So when we have an equals to 4n square minus 4n plus 1, this is the answer for your sum, and the answer is n by 2 bracket 2n plus 1 2n minus 1, and this is how we solve it. Okay, and you just be careful with this one. Okay, if you have just number 1, then we just write sigma 1, but I just explained to you, if you have any other number, then you imagine that number into 1, so the constant, that is any other number apart from 1, comes in the front and the 1 stays at the back. Okay, so these are the various types, so it's quite simple. So this is how we go ahead and solve questions when an is given to you and the sum is asked to find for these kind of questions. Okay, so I hope this is quite simple enough, you'll be able to understand, and in case if you have any queries, you can always ask. That means you can always send in your comments, and then we'll just go ahead and check if there is anything that extra that I need to maybe explain or maybe mention in these kind of tutorials. Okay, so that's it for the time being. Thank you very much.